Hello everyone. So welcome to the lecture on reciprocity theorem. The name itself tell you that is we are talking about something related to reciprocal. Yes. Now if we read the sentence of the reciprocity theorem directly, it will be a little bit confusing. So we will understand the theorem first by this circuit diagram. Now look at this block. This is nothing but a network, and I have just highlighted two different branches. This is branch A dash and this is branch B dash. Now here I have connected a voltage source to the A dash branch, and because of this voltage source there might be a current I flowing into this B dash branch. So this source I am calling it as excitation, and this current I am calling it as a response to this excitation. So these are terms we'll be using with respect to reciprocity theorem. This is excitation and this is the response. Now the reciprocity theorem states that in this network, if you interchange this response and the excitation, it will not affect the value of the current. This is the reciprocity theorem. See, now look at this first diagram. What I am going to do is I am going to place the source V on the branch BB dash, and I am going to take the current I in the branch A dash. Look at this diagram. See, this V is brought to this branch, this I is brought to this branch. It is actually reciprocated. So both are we have done a reciprocal of it. Okay, we have done the reciprocal of source and the excitation and the response. So even if you do a reciprocal of it, it is not going to affect the value of the current capital I. That is what your reciprocity theorem states. We will have a more clear understanding with the help of a simple circuit. So now this is a circuit given to you. You have a voltage source plus minus 20 volts, and you have a series of parallel combinations of resistances. So they have identified two different branches. See, this is one branch AB and this is another branch CD. Okay, right. So first we will mark the excitation and the response element. So we will mark the source and the response. Here I am going to mark this as the branch. See, I have named this as this branch. I am going to consider this branch as the excitation. Okay, and I am going to consider this branch as your response element. Okay, so what we will do is first we will keep the circuit as such, and we will find out what is the value of current I. Okay, இதே circuit அப்படியே வச்சிட்டு we will find out what is the value of current I. And then what we will do is we will interchange these two. We will bring this branch to this side and we'll bring this branch to this side, and then we will find out the value of current in that case, and we will check whether both the current are equal or different. Okay, right. So in the first step, what we'll do is I'm not going to disturb anything. I'm going to have the same circuit as such. Okay, now here it is 20 volts. So I'm not disturbing the nature of the circuit now. This is your source and this is your response. So we will find out the value of current I. You can try with n number of methods to solve this problem. You can go for mesh or you can go for nodal, anything whichever is easy for you. So what I'm going to do is here I'm going to apply current divider rule to find this uh, value of this current I. Okay. So in order to find the value of this current I, first, I have to find out what is the value of this total current T, because this current only flows like this and get divided like this. No, it divides like this. Again, this current gets divided like this. So what I am going to do is I'll first find this current, okay, and then I'll find this current. So when I find this second current, then with this current I can apply the current divider rule, because you know what is current divider rule? It is total current into opposite resistance divided by total resistance. So I want the current in this branch, so I want this total current, that is number 2. In order to get this number 2, I want this number 1. Okay, so we'll first find IT, and then we'll find the current flowing through this 2 ohm resistance, and then finally we'll find the current flowing through this final 2 ohm resistance. Okay, I'll explain this problem step by step. The next part that you have to try it by yourself. Okay, first in order to find out this IT, okay, first to find out IT, what you have to do is you have to simplify this network. So how to simplify this network? Now look at these two network. It is nothing but both are parallel. No, so if you take these two resistors are parallel, it is 2 into 2 divided by 2 plus 2. So it will be 4 divided by 4. It is nothing but 1 ohm. Okay, right. So this 1 ohm and this 2 ohm are nothing but series. Series means you can directly add it. So it is 2 plus 1 is equal to 3 ohms. Okay, right. Then this 3 ohms and this 3 ohms are nothing but in parallel. If both are in parallel means it is 3 into 3 divided by 3 plus 3, that is 3 3s are 9 divided by 6. So you will get around 1.5. Okay, right. This 1.5 and this 2 are in series. So when you add these two, what will you get? It is 3.5 ohms. It is an ordinary resistive network simplification method. Now the circuit has become like this, correct? The circuit has become like this. One is 20 volts, okay? This is 20 volts, and this is resistance. This is 20. I take plus minus, and this is 3.5 ohms. So now you can find out the value of IT. So what is IT? IT is equal to, it is 20 divided by 3.5. It is equal to 20 divided by 3.5 is, it is 5.71 amps. So we have got the current as 5.71 amps. Okay. So it is now this current is 5.71 amps, correct? So this IT is 5.71 amps. Okay. But we are more concerned with finding this current, no? So in order to find this current, I want this current. Okay. So what I can do is I'm going to combine, I'm going to represent this network like this. How means, just see how I'm going to represent this. So I'm just representing the circuit like this. So that means I'm going to keep as such all these resistance, and then I'm going to combine these three. How to combine? So you combine these two. This is these two are parallel. So 2 and 2 parallel means it will be 1 ohm, and that 1 ohm and 2 ohms are nothing but series. So you know it becomes 3 ohms. Correct? Now you can find out the value of current like here using a current divider rule. So what does your current divider rule states? Current divider rule states like total current into opposite resistance, okay, divided by total resistance. Yes or no? So what is total current here? It is 5.71, okay, into the opposite resistance means this is 3. I am concerned with this resistance. So opposite of this is 3. So it is 3 divided by 3 plus 3, that is 6. So it will be 5.71 divided by 2. The current will be, it is around 1.4. I'm sorry. It will be, it will be 2.85 amps. Okay. Right. Now we'll go to the next step. So when you look at this diagram, now we have found out this current 2.855. We are very much concerned in finding this current value. Again, apply current divider to this. So total current, that is 2.855 into opposite resistance, the resistance opposite this is 2. Divide by total resistance means it is 2 plus 2, that is equal to 4. Again it will be half of this, that will be 1.43 amps. Okay, so now we have found out the answer, which is nothing but the current I is equal to 1.43 amps. The current I is equal to 1.43 amps. Okay, right. Now what we are going to do is I am going to interchange the resistance. So first part is over. Now I want to interchange this source and the response. So just observe what it is done. This 2 ohm is brought to the front, and the source and 2 ohm, this branch is brought to this end. Now the circuit becomes like this. Okay. When in the now in the, you have to find out the current I to this 2 ohms in the same way which I taught you now. When you do this usual procedure, you will get the current I is equal to same 1.43 amps. So you can try the circuit as a homework and you can verify this. So this tells you that even if you interchange the source and the response, the ratio of the source to the excitation to the response is going to remain changed. So in both the cases, the current will be getting it as I equal to 1.43 amps only. Thank you.